Okay, so I'm recording this. Okay, good. All right, so today what I want to do is talk a little bit about law of cosines, and if you have the side case, something that I forgot to emphasize last time, and I want to talk about that. Then we're going to go over the triangle trig reference sheet, which needs one correction. So I want to make sure you correct it or you printed out the new version. And then what we're going to focus on today is solving application problems. So we've done law of sines and law of cosines, and now we're going to take those problems and put them into some context so that we can use them to find, something that might apply to something kind of in real life. Still a little made up. But okay, so we're going to try those application problems. I don't think we'll finish the notes. So for homework, I made videos of the last two examples. So depending on how far we get, you'll probably have to watch those. And then there's a worksheet on Canvas. Okay, please note when you do that worksheet, there's a mistake in the key that's noted on Canvas. It says, the answer to this problem is something else. Okay, so when you access that, you'll see it. Okay, so the clarification, Gabi, welcome. Okay, so the clarification is, if you're using law of cosines and you have a side, so let's say we have some triangle and its side lengths are, let's say 5, 7, 9. If we use the law of cosines here, which we can, we have a choice as to which angle to choose. So let's say I'll label these A, B, and C. If we find the largest angle first, we can potentially avoid some problems because after we use law of cosines to find one angle, we'll typically go on and use law of sines to find the next angle, because then we'll have a ratio with an angle and an opposite side length. So in order to avoid problems, if we find the largest angle first, then we don't have to worry about the possibility of our second angle being obtuse, right? Because in a triangle, how many obtuse angles can we have?
Just one, right?
Just one. We can only have one obtuse angle, right? So if we find the largest angle, that will be the obtuse angle if there is one, right? There may not be one, so it'll be acute. So if in this triangle ABC, if I were going to use law of cosines, which angle would we want to find using law of cosines?
B, right?
Yeah, we'd want to find B, right? So we want to find angle B. And Gabi, how do you know we want to find angle B?
Well, that's the longest, or side B is the longest side, right? I mean, also just kind of looked at it, like compared it to angle A and C.
Yeah, but it may not be drawn to scale, right? But if I drew this better, right, the largest angle will be opposite the longest side, okay? Because largest angle, I'm running out of room, is opposite longest side. Okay, and that'll just avoid possible problems, because remember with law of sines, sometimes we have to find that supplementary angle, so we get one angle that's acute and then we have to check the second one. So just for good practice, find the obtuse angle first, and then you can use law of sines without worrying about the second angle. Okay, everybody good with that? Okay, so please ask if that doesn't make sense. Okay, great. All right, so what I want to do now is take a look at this triangle reference sheet, triangle trig reference sheet. So this is a summary of what we've talked about so far. Okay, so everything on one page that we've been talking about. So we have law of sines, and we have two versions. Remember, if we want to find side lengths, then you want to put the side length in the numerator. You don't have to. You could always cross multiply, but this will save a step. And if you want to find angles, put the angles in the numerator. Okay, and then law of cosines, remember this is a modified Pythagorean theorem. We could write it in 3 ways. It doesn't really matter. And those are the two laws. And then what the rest of this page does is it goes over when to use each of the two laws. Okay, when each one is relevant. I don't really recommend, so down here I have a note. I don't really recommend you memorize these cases, okay? Because I think it's easy sometimes to get confused by that. But I do think it's easy to remember when you can use law of sines, right? So in order to use law of sines, you have to be able to complete one ratio, right? So if you have, let's say, A over sine A equals B over sine B, if you can't complete one full ratio, you cannot do law of sines. So if you attempt to use law of sines and you don't have a complete ratio, it's not going to work. And then you're going to have to use law of cosines. Okay. So as a default, you can always check and see, can you use law of sines? If not, then you're going to have to use law of cosines. But let's go through the cases. Okay. So we're going to use law of cosines if we have side, side, side. Okay. So if we have side, 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 can we set up those ratios where we have sine A over A equals sine B over B equals sine C over C? No, right? We can't set up. So law of sines won't work. We have to use law of cosines, okay? If we have side, 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 we're going to be solving for this angle, right? That's pretty obvious because we already know the sides. So, and which angle do we want to solve for first? Actually, I don't really, this diagram, we could find X, but which one should we solve for first?
Like the one across from 12.
Yeah, good. So we really want to solve for this angle first. Great. Okay. Then if you have the side angle side case, then you can solve for this missing side. You can get the third side. Okay. So if you have two sides and an included angle, you can use law of cosines to find the side opposite the angle. And then for law of sines, we have the side side angle. I want you to be careful. That's the ambiguous case, right? So that's the one where we're going to have to look for two possible angles, right? The acute angle and the obtuse angle, make sure that both work. And then if you have angle side angle or angle side, you can always find the third angle if you're given two of them, right? So in this case, you'll be able to use law of sines. Okay, so this is a good reference for you as you're working through problems and to help you study. Okay, everybody good with this?
Wait, when's our test?
I'm not 100% sure yet. I will let you know. Probably sometime next week.
Okay.
Okay. The mistake that was in the previous version, I think this said ASA twice. So if you printed it out early, make sure you have ASA or AAS. Because initially when I typed it up, for some reason, I typed the same thing twice. Okay. Everybody good? All right, so now knowing what we know about law of sines and cosines, we're going to dive into some of these application problems, okay? And they can be a little bit challenging, especially if we're not given a diagram, okay? So we're going to work through these. Please ask questions as we go so that we can apply these problems. So let's see, Aria, will you read this first problem for us?
Yeah. The original height of the Leaning Tower of Pisa was 184.5 feet. At a distance of 140 feet from the base of the tower, the angle of the elevation from the ground to the top of the tower is 59 degrees. How far is the tower leaning from the original perpendicular position? Your answer should be an angle.
Okay, so I'm going to redraw this triangle because even though this is a really nice picture, it's hard to write on there and see it. Okay, so I'm going to sketch the diagram over here on the side. So we've got 140 feet on the base. Then we have the height of the tower, which is leaning. And then I'm going to connect that. And now we have our nice triangle. I'm going to label in 140 feet. I'm going to label this side length 184.5 feet. And we're also told the angle of elevation, which is in the diagram, it's just really hard to see. That's 59 degrees. And I'm going to label the vertices just to help us talk about the triangle. Okay, so A, B, and C, capital letters. And that means I can label little a, which is the length of BC, and little c we know, and little b we also know. Okay, so looking at this triangle, we want to find how far the triangle is leaning. Okay, so I'm actually going to draw in the vertical line, the perpendicular, where the tower should be if it weren't leaning. And so the angle we really need to know, actually, I'm going to move my C because that's in the way. Let's see if I can just get that. Yeah, that's in the way a little bit. Now I got to redraw my line. Okay, and I'll redraw this line.
Wait, Mrs. Terrace?
Yeah.
Are these numbers, are they accurate? Because this could be a really fun fact to know.
I think they are. Yeah, I mean, Miss Galante made up this problem, but I think that they are.
Oh, I can go brag to people that I know this now. Okay.
Okay, so the angle that we want to know is this little angle here that I'm labeling theta. Okay, that's how far the tower is leaning from the vertical where it should be. Okay, from the perpendicular position. Okay, so suggestions as to how we can start solving this problem. Okay, what case do we have in terms of our triangle? What information do we know? Which of the laws can we use? And how can we eventually get to the theta that we want, how far it's leaning? Yeah, Aria.
I'm not sure how much this would like be able to do, but can't you do law of sines and find little a?
You could do law of sines and find little a. That is true. Is it going to be helpful to find this length though? So we could find it. So Gabi, you asked about that in one of your homework problems, right? We can always find extra stuff, but that is probably not going to help us to find little a, right? Janie, what do you think?
Well, we have side angle,
Good.
triangle.
Yep.
So like that, when we do the like 180, like the you know, when you find the two angles, will that help us?
If we find the two angles, which angle?
Oh, I don't know. Either of them? B.
Yeah, we could find either end. We really like to focus on angles. So Aria was right. We can use law of sines. We can use law of sines. But really, we'd like to focus on angles for this problem because I really don't care how far it is from the top of the tower to wherever the person was where they measured the 59 degrees. But I do want to know about angles. So Aria's right. Let's do law of sines. Janie is right. Let's focus on angles. Okay. So which angle can we find right now using law of sines?
B.
We can find B, right? Because we know 140 feet, we can find the angle opposite it. We don't really want to know B, we really want to know angle A, but we'll have to do it step by step. Okay, so let's set up, what's our proportion to set up to solve for the measure of angle B?
Isn't it angle C over little c and then?
Yep, so sine of 59 over, you're right, Aria, keep going. Or was that Janie?
It was Aria, but
Aria, yeah. Yeah, sine 59 over?
140.
59 goes with the
Or
one that's
sorry.
opposite. Yeah.
Sorry, 180. 184.
Good. 194.5 is going to equal to?
Sine B
Yep.
over 140.
Terrific. Okay, and let's figure out what B is. So what should I do?
You multiply the 140 by both sides.
Good. So sine of B is 140 sine 59 over 184.5. And we'll get some value for that. I got it was 0.6504 dot dot dot. You guys get the same thing?
I got 0.65.
Yeah.
You get 0.6504 something?
Yes. And then
Good. And then take sine inverse of that. Remember, just copy that value down in your calculator so that you don't get rounding errors.
And then it's 40.6.
Good, 40.6 degrees. So I'm gonna go ahead, I'm gonna put that into my triangle. 40.6 degrees. Great. Okay, what should we do next?
Oh, we could find, well, I don't know if we need to find angle A.
Yes, we would like to find angle A. What's the
You
measure
would?
of angle A?
All
Oh,
right.
oh, wait, we just used law of sines though, right? What's the other possibility for the measure of angle B? Or do we care about that?
Oh, it's ambiguous, so we
don't
do
care
need
about
another one.
We don't
Well,
care.
let's check if the other one is even possible, right? The other possibility would be the supplement, right? So 180 degrees minus 40.6, and that's 139.9 degrees.
So in order to find like the other value, you do 180 minus the first value for B that you got.
Yeah, so let's find, okay, so let's see what A could be. So the measure of angle A, so I have two possibilities, right?
Wouldn't you do 90 minus?
Why 90?
Because it's like a straight up, it's like that.
Oh, eventually we're gonna do 90 minus what we got for A. That's how we're gonna find theta, but I have to check if that second possible angle works for B, right? Because this is the ambiguous case. So I need to check.
If you're only finding angle A, you have to do that?
Oh, right. So, but I have to see if B is even, this second B is even makes sense. And that
get a
we do that by
negative.
finding A.
But isn't the second B like not relevant here because we're trying to solve for A?
No, because there could be a different A, like if there's more than one B possibility.
Okay.
Yeah, so
180 minus 59 minus 139.4, that gives you negative 18.4. So that can't even work really, right?
that doesn't work. So you're right, Janie, it does not work. So this is negative. So forget this, okay? I just don't want you to forget about the ambiguous case that you need to check it. Okay, so that doesn't even matter. Okay, so what is the measure of angle A that we want?
Here, 180 minus 40.6.
80 degrees.
Or 80.4 is what I got.
Good,
Yeah.
80.4 degrees. Very, very nice. So that's the measure of angle A. I'm going to put that in our triangle, 80.4 degrees. And now our theta is how far it is from the perpendicular. So how can we figure out what theta is?
So 90 minus 80.4.
Very nice. 90 minus 80.4, which is going to be 9.6 degrees. So we say the tower is leaning 9.6 degrees from the original perpendicular position.
Wait, you did. Oh, because we solved for B. Okay, yeah, that makes sense.
Everyone good on this one?
Yeah.
Okay. Okay, you done writing?
Yeah.
Okay, Gabi, will you read the next thing about Candace and Dorothy?
Yeah.
Great.
All right. So Candace and Dorothy are sisters and are leaving to go to college at the same time from the same airport, traveling in opposite directions. Their very sad mother is watching the airplanes fly away. Oh no. To distract herself from her sadness, she decides to do a little math. I like this one. She measures the angle of elevation to Candace's airport to be 31 degrees and the angle of elevation to Dorothy's airplane to be 24 degrees. At this moment, her phone app shows that Candace's airplane has an altitude of 7 miles and Dorothy's airplane has an altitude of 4 miles. How far away are the two daughters at this moment?
Okay, so we're gonna help the poor mom and figure out how far away they are. Okay, so suggestions as to how we can start putting all of these, all this information into our diagram.
Can we draw a line between the two planes?
Yes, that's what we want to find out. Okay, that's what we're interested in finding, is that side of the triangle. Good. Which plane is Candace and which it has Dorothy in it?
Yeah, but Candace is 31. So the one with the smiley face?
The one with the smiley.
Oh, no.
These are not drawn to scale. So
Yeah, I just realized that.
I think this should be Dorothy and this should be Candace, only because of the heights. And the Candace's airplane is supposed to have a higher angle of elevation. Okay, what else should I draw in here?
The angles.
Okay, where do the angles go?
So it says Candace's airplane is at 31 degrees and Dorothy's is at 24.
Okay, so what does that mean, the angle of elevation?
Isn't that just like from where the mom is, the angle from where the mom is to the airplane?
Yeah, from the horizontal. So we need to draw in the horizontal.
Oh,
Okay, so angle of elevation is always measured from the horizontal going up. Angle of depression is always going down from the horizontal. So Candace's airplane is 31 degrees. So I'm going to put in the angle of elevation there. And Dorothy's airplane is at 24 degrees. So I'm going to put in the angle of elevation there. And then I'm going to drop in altitudes here. So these, we actually have some right triangles.
So then the angle in between would be 125.
Yeah, how'd you get that?
Oh, because like it's a straight line, so you know that it has to equal 180. So you can do 180 minus 31 minus 24.
Very nice. So this is 125 degrees, right? Together they form 180. Very nice. Okay, what about the heights, the 4 miles and the 7 miles? Where do those go?
On the like the verticals, like
Yeah, the vertical segment.
the triangles, yeah.
Yes, on the right triangle. So where's the 4 go? By Dorothy or Candace?
Dorothy on the
Dorothy.
right.
Dorothy. Okay, so 4 goes by Dorothy. 7 goes by Candace. Okay, and we want to find the segment CD. What should we call that? Because that's our goal, is to figure out what that is. What letter do you want to use?
M for mom.
M for mom. Okay, because it's opposite mom. Okay, so that's our goal. We need to figure out that distance M. Okay, so suggestions. So we're sometimes on these problems, we're going to have to use what we know about right triangle trig and the law of sines and cosines.
Right. Do we want to figure out the sides between, or like the length of the sides between Candace and mom and Dorothy and mom?
Yes, I would like to find those. I think those would be helpful. I'm going to call this little d and this little c, okay? Because they're opposite c and d. So I would like to find little d and little c, because that'll give us the triangle that we're really interested in, right? That big triangle CMD. Okay, so how can we find little d?
Use sine.
SOHCAHTOA.
Yeah, let's use SOHCAHTOA. Great. Let's
Sine.
use, so sine of,
31 degrees
yeah,
equals 7 over d.
very nice. So now with this one, we have to cross multiply, I guess. Or just multiply by d and then divide. So d sine 31 equals 7. And then finally divide by sine 31. Oh, I put an extra equal. Yes.
Another way to do this. Well, if you want to find do you want to find the angles of like between like the okay, like if you imagine it's a big triangle. Oh wait, would that even work? Like I'm just thinking like the overall angle from like, so picture at like the right angle on the left side, like at the horizontal, from there up to Candace, and then like from Candace to Dorothy, like without even like the 2 diagonal lines we made like for the mom.
Yeah.
Do we want to know those angles too?
No, we don't care about that.
Those,
so just like at the beginning, let's not find stuff that we don't need to know. Even though we could find them, it's not going to be helpful.
Gotcha. Okay.
Okay. So what you get for D?
13.
Negative 10.9.
You got negative 7 over sine 31.
I got 13.6.
Yeah, I did too.
Are you in radian mode, Aria? Check your calculator. See if it's in radian mode.
Oh, yeah, it was.
Okay, because that's how, if you're getting a negative value for something like that, check that. Okay, good. What should we find next?
Then do the same thing for the other side. So like
Good.
sine 24 equals 4 over c.
Right? So
And then
equals
that
4.
all equals 9.8.
So that equals to 4. So C equals 4 over sine 24. And you said C was 9.8.
Yeah. And then
Great.
you can do m squared.
Okay, so now we're gonna go to triangle, let's call it CMD, right? And what kind of triangle do we have? You're right, Janie. So this is a side angle side, so we're gonna use law of cosines. Okay, so Janie, go ahead. You could set it up for us now.
Okay, so you do m squared
Yep.
equals 13.6 squared plus 9.83 squared minus 2 times 13.6 times 9.83 cosine of 125.
Yeah, I ran out of room, so I'm gonna rewrite it. You keep going. I'm gonna rewrite
now
it because
I'm
ran
gonna
out of room.
use my calculator values to like find the squares and stuff.
Good. Yeah, just you can punch everything in.
Oh, right.
Yeah, just punch everything in. I got that m squared was 434.766. You may have something a little different if you round it, but it should be close. This should be 20.9.
Wait, you got, yeah, okay, I got the same thing.
Yeah, so it might be slightly different if you rounded. I didn't round. I just took all those values from the sine law of SOHCAHTOA portions. Okay, how's everyone feeling about those?
Good.
Good? Okay. All right, let's go on to the next one. Okay, Janie, will you read the one about the ships for us?
Two ships 1,600 feet apart detect a submarine between them. The angle of depression from the ship to the submarine is 40 degrees, and from the second ship is 28 degrees. How deep is the submarine?
Okay, so angle of depression is measured from the horizontal, just like angle of elevation. Okay, so we need to modify this diagram so we can put in the relevant information. What do you suggest that we draw?
Well, I'd like to just draw the like make it into a triangle.
Yeah, let's draw the triangle. So we'll connect the ships and each ship to the submarine. Great.
And then
Fine.
the two ships are 1,600 feet apart.
Good. So let's put that on here. So 1,600 goes across the top.
Okay, the ship to the submarine. Well, there's two ships.
Yep. So I'm going to call the one on the left ship A and the one on the right ship B. I'm going to put C by the submarine. Okay, so then we can talk about it.
And then draw two triangles kind of like off of both of them. Two right triangles.
Okay, where are you putting the right triangles? Like here?
Yeah.
Okay, so where are you going to draw in the angle of depression? Where does that go?
Like where the submarine and the horizontal meet.
Yeah, so this is actually 40 degrees, right? And the other one is 28. So the angle of depression is always from the horizontal going down. So it's not going to be, this angle over here is not the angle of depression. So we could draw in that triangle. I don't know if we need to. So I think I don't want to do that. I think we could probably get rid of
the submarine. It's from the ship. Like,
yeah, so the angle of depression is going from the horizontal on the ship down into the water. That's what 40 degrees, that's where the 40 degrees is. That's what the angle of depression means.
okay.
So these are always from the horizontal. So angle of elevation is above the horizontal. So draw something horizontal, then go up for angle of elevation. If it's angle of depression, draw the horizontal and then go down. And those angles always go back to the horizontal. They're like the reference angles. They always go back to what might be like the x-axis. Okay.
So then we should draw like a dot dotted triangle like through the middle of this triangle, I guess. Like,
Yeah, nice. Let's draw in then altitude, right? That's the depth. Right, and this, since we made it perpendicular, since it's an altitude, it's gonna be a right angle there.
And did we cut it in half? Like we cut
No, because it's not isosceles,
it- okay.
right? Because the submarine isn't halfway between the ships horizontally, right? It's shifted around.
Okay, but we can still find what the angle is.
Okay,
So we could do 180 minus 40 minus 90.
okay, so that's this big angle here. So 180 minus 40. Oh wait, which one are you finding? Which angle?
Oh, I was finding the angle for like the left side triangle.
Okay, so let's do the left side. We can do it that way too. We can do it in 2 steps.
Okay,
Okay.
yes, that's 50.
So- Okay, so this is 50, because that was 180 minus 40 minus 90. Okay,
And then the other one is 180 minus 28 minus 90, which is 62.
okay, so this is 62. So the whole angle is going to be 112. So this big angle is 112 degrees. The sum of those two, right? 50 plus 62.
Yeah.
Right. Okay, so
I feel like you wouldn't need to know the sum. I feel like you could just do like pick one of this. Or actually you do.
okay, so I understand if we knew one of these lengths up here, then we could just use SOHCAHTOA on one of the 2 triangles. I agree. But we do not know where that altitude comes in on the 1,600-foot side.
Oh, okay.
Okay, so your idea is a good one, but it isn't going to work directly. We're going to get there eventually, but we can't do it yet, right? Because we don't know that piece that I just highlighted in yellow. Okay, so we have to focus on the big triangle ABC. So what do we know about triangle ABC?
A side and an angle.
We knew a side and
side. We know 3 angles.
yeah.
A side.
Yeah, so this is actually angle, side angle. And we found the third angle. You can always find the third angle if you know 2, right? So if it's angle, side angle, we could do law of sines on triangle ABC. And we don't have to worry about the ambiguous case here, yay, because it's not the side angle. Okay, so Aria, will you help us set up law of sines? And we need to determine which side we want to find, right? So I'm going to call this side little b and this other side little a. Which side would you like to find?
Little a.
Okay, little a. Okay, so let's do it. What do we set up? We want to find little a.
You do 1,600 over sine 112.
Yep.
And then equals a over sine 40 degrees.
Very nice. Keep going. Doing great.
And then multiply sine 40 by both sides.
Yep.
And then you do a equals 1,600 sine 40.
Yep.
Over sine 112, and then that equals.
Yeah, see what you get, because I solved it differently, so I don't have this one. I found B.
I got 1,109.2.
1,109.2. Did you get it too, Aria?
I haven't finished, but
Okay.
yeah.
Okay, terrific. Okay, now, Janie, we can use your idea, right? Because now we can focus on the right triangle, right?
Okay.
The right triangle on the right, right? So if we focus on that triangle, we'll be able to find the altitude that we want, okay?
Mhm.
So I'm going to call the altitude that we want, I'm going to call it little x. Okay, that's really what we want to find. So now we can use SOHCAHTOA.
Oh, right, because the right triangle. We don't even have to do all of that. So.
Yeah, with right triangle on the right. Okay, So what ratio can we set up now if we're just focusing on the right triangle on the right? If we want to know x.
Oh, we can do sine,
Yeah, sine is right.
yeah, we can do sine 28 degrees
Yep.
equals x
Yep.
over 11,000 or yeah, 1,109.2.
Very nice.
And
Good.
then you multiply both sides. So that.
Okay, so it'll be 1109.2 sine 28. And if we punch that in the calculator, hopefully we're going to get 520.8.
Yeah.
Is that what you got? Okay,
Yeah.
great. Okay, so the ship is 520.8 feet deep. I like to answer these questions in a sentence. I know some teachers don't require you to do that, but I think it's a nice way to like make sure that you're answering the question, not just saying, you know, what x is, what is x? I don't know, right? All right, how we're doing on time today? I'm going to check the schedule because it's a different schedule. 11:16. Okay, so we have 6 minutes. Okay, so we will at least start the next problem. If we don't finish it, I will probably make a video of problem 5 too. I have to see how far Miss Galante gets as well. Okay, so I'll send you an email with an update about how we're going to finish these notes. Okay, so let's at least try to set up this next problem. Okay, so Gabi, will you read this for us?
Yeah. Do you want me to also read the lead of these types, or?
No, forget that. This is, we could solve these problems using vectors, but now we're going to solve them using law of sines and cosines. Because remember with vectors, we created triangles, right? And then they weren't always right triangles, so we had to solve them using vectors, but now we can solve them using law of sines and cosines. So go ahead, just read the problem.
All right. An airplane is flying directly east at a speed of 400 knots, and a wind of 50 knots is blowing directly to the northeast. Find the speed and direction of the path of the plane.
Okay, terrific. So an airplane is flying directly east. Okay, so I'm going to start making a diagram. So north, south, west, east, so that I don't get confused with my directions. Okay, so the plane is flying directly east. So we're going to draw its vector. So 400 knots going to the east. I'm going to call it vector P. Okay, then what else do we know?
Oh, we know of the wind.
The wind, it's blowing at 50 knots directly northeast. If it says northeast, that means it's an angle of 45 degrees from the horizontal, right? So then I'm going to add the wind. So the wind is here, and it has a length of 50, and this angle here is 45 degrees. And we would like to find the resultant speed and direction of the plane. Okay, so I'm going to connect that, right, like we did before. And so this is what I really need to find. I'm going to call it R, right? That's what we did when we were doing vectors. But this problem is going to be a lot easier, I think. Well, I guess it's about the same. I don't know if it's easier, just different. Okay, so we want to find the magnitude of R, right, the length, and the angle, right? So suggestions as to how we can use law of sines and cosines to solve this problem.
Well, we can to find the biggest angle in
Yep.
that triangle.
Yeah, what is that? What is this angle here?
It's just 180 minus 45, so 135.
Good. So this is 135. Nice. So now it's looking pretty good, right? We have a side angle side case. So if we have side angle side, we can find the length of the side opposite the 135, right?
Yeah, so you could do r squared.
Yeah, so let's do that. So r squared is equal to
400 squared.
400 squared plus
50 squared.
Yep, 50 squared minus
2 times 400 times 50
Yep.
times cosine of 135.
Okay, and this is the one where you just enter everything in. When I did this, I got 190,784.27. See if you agree.
That's what I got.
Okay, great. And then take the square root of that.
Oh, I didn't do it in my calculator.
I got 436.78.
Good. And I'm just going to round it to the nearest tenth here. So it's 436.8 knots. That's the magnitude, right? That's its speed. Okay, so this is the speed. Okay, and how can we find the direction? Where is the direction? Which angle is it in our triangle?
The directions that it's like the angle on the left.
Yes, the angle on the left. This is theta, right? Yeah, so how can I find theta now?
You could do
180 minus 135 minus 45.
45 is not in the triangle, so that's not, I don't know that second angle is 45. Not a bad idea, but it won't work.
You could
Yeah,
do
Jamie.
law of
How
sine.
are you? What can I do? Law of sines. Yeah, I could do law of sines. Let's set that up. So we could do sine of theta over the side length opposite it, which would be 50, equals sine of 135 over the length of the side opposite, which is what we just found. So 436.78 ... Okay? And then if we multiply both sides by 50, we get sine of theta is 50 sine 135 over 436.78 ... And when I punched that in my calculator, I got 0.0809. And then theta is just going to be sine inverse of that 0.0809. And I got that was 4.6 degrees. Okay, so I'm just going to write my concluding sentence. The plane is flying at 436.8 knots at 4.6 degrees. I'll fix this so it's more legible. Okay, great. So thank you for working with me today. I'm going to make a video for number 5. I already made videos for 6 and 7. I will send you the links for those. And then on Friday, I think we're going to start reviewing for the quiz or test on, I'm not sure if it's going to be just law of sines and cosines or if it's going to be the unit circle too. So Ms. Galante and I are trying to decide that. Okay, but I'll let you know. Okay, so for homework, you'll do 3 more application problems and then with the video, and then there's a worksheet on Canvas. Okay, so I appreciate you're spending some time outside of class, but I think that's all that I can do given we have just half the amount of time. Okay?
Yeah.
Okay.
And
All right.
Thank you.
law of sines and not the unit circle.
Wait, why are we?
Oh, you just want to be law of sines and cosines, not unit circle.
Yeah.
Okay, I will accept your input.
Seriously, why are we doing the unit circle again?
Why are we doing unit circle? I don't know. We'll see. I'll let you know. All right, have a great day, everybody.
Okay, you too.
Okay, bye-bye.